Okay, hello everyone. This is going to be a somewhat general Git, Gerrit, GitHub, that sort of thing, um, tutorial or training. Given that it seems that many people run into some small problems here and there around this, and perhaps overviewing some of the concepts there and just what's normal and what's not normal is useful to overview. So initially I would focus on some general Git tags, and in case that's boring for you, don't panic. In 2 slides we will get to somewhere else, but it's very useful to understand what's the difference between rebasing and merging, in case that's not totally clear to you. In case there is one single slide that you take home from this talk today, then perhaps this should be it, because it's very useful to understand this correctly. So you assume that, what's the situation, what's the use case? So assume that you clone the core or online repo, and you just take the latest state without thinking too much, and you start creating your changes. You create some commits A, B, and C. And it turns out that there was some random latest version of that master on the remote side that is the baseline of your work. And in the meantime, also the remote master advanced by 2 more commits, and you have 3 local commits. Then you now have 2 separate states. You have a local state, that's commit C, and there is the remote state, commit G. And either by rebasing or by merging, you want to somehow make sure that these 2 states are actually one state, because this is happening all the time, that we are a distributed team working on the code base, which means that you need to create your own local fork. You work there, and then you want to submit back your work and then start again. So we do this a lot. So the way rebasing is solving this problem is that we are here at this commit C. And what we do is that, of course, we back this up, but apart from that, we go back to this commit E, and then we forward to the new remote state, that's commit G. And on top of that, we rebuild everything that you did manually, locally. So we create a new A prime, B prime, C prime commit, and with that you get a linear history. This has the downside that there was the old A and there is the new A commit. So there are 2 versions or many versions of the same book. But the benefit is that there is a linear history, and that, of course, makes reasoning much easier. In theory, you could do also the merging, which is popular in other projects, but we don't do this in LibreOffice or Global Online, where what you do is that you leave your commit C and the remote G unchanged, and you create a new commit H, which has 2 parents, and then it combines these 2 states represented by these 2 commits. And basically, in case you examine what's the contents of the files, then the state C prime and the commit H is exactly the same, but how you arrive to the state is different. Merging will preserve the original ABC, but then it will be harder to traverse this history because it's no longer linear. And in case you do the rebasing, then it's linear history, but you will have multiple versions of your local work, so that complicates things a little. To the side, we can look at another Git thing. How do you diff different states? It's not too complicated, but it's worth understanding the concepts there. So the original problem that is solved by introducing a Git index is that you have this use case that you have local changes in various files in your working directory, and you don't want to commit all of them. So what we do is that you stage some of these changes to the index, which is kind of the to be committed state. And once you are happy with what's in the index, then you do the git commit. So by staging, you do this git add, which is a bit confusing. In other version control system, git add was only for adding new files. In git add is also adding the new state of an existing file. So what you have is that you have the working directory. This is what you are editing with your programming editor. And then optionally, you can do a git add to stage either the entire new version of the file or some hunks from that file to the index. And then from the index, you can commit that to the object store. And then you have three places where you can fetch state. You have the object store, what's committed at least locally. You have the index, and you have the working directory. This also means that in case you modify some file and you do a git add, then all your modifications are already in the index. So you modify the file. You did not commit that, but diff won't show that because diff is comparing the working directory and the index, which might be confusing in case you don't understand the concept. So we have four ways you can compare states. I explained the working directory versus index. Now there is this, you stage some of your changes to the index and you want to review what will be actually committed. There's the cached diff. Diff cached is comparing the index and what's committed, the object store. In case you want to do a full diff between the working directory and what's committed, the object store, you can diff to the head. And the last thing is that for various already committed states, you can always do a diff, and you explicitly say what's the order new commit you want to compare as a state, and then you can diff between these things. So hopefully, in case that was confusing previously, then perhaps this should clarify. Apart from that, I would like to share some tricks related to Git, which can speed up your workflow in case you would miss out on that. So a push tree is something that I'm sure I was not the first one to invent this, but I did not really see that written down anywhere. So there is a blog post going into details. But the problem is that especially for core Git, you can have this problem that you want to push your changes, but in order to push, you first need to pull because we use this tree-based workflow. And in case you pull, that might cause a large rebuild. It can take more than an hour of your time. And in case you are in the middle of your productive hours, that's a bit painful. So what we can do is that you have your working repo, and you have a separate push working repo, push tree. And instead of pushing directly, you always first cherry pick to the push tree, you push from there. And you only pull in your real repo when you are not busy or you do something else and it does not bother you that you can't have a fast compile, tryout, hack cycle or iteration. Another thing that can be useful in case you are not aware of that is that we have many branches, and also inside branches we have many configurations. So let's assume that for core you want to have the CO2404, you want to have master, perhaps other branches, and then for one branch you might want to have a debug build, you want to have a product build, you might want to have a symbols build, and so on. So that means many clones. And I see that somebody has a question, but I'm sharing the screen, so I don't really have more information than that. So shoot, please ask. It's perfectly fine to interrupt me. Was there just somebody?
Arsha, did you want to say something? I think it was. Okay. It was misclick.
Okay, great. So one thing what you would mainly do is that you reclone the entire code Git and online Git all the time. Given that, like, I did not measure that recently, but I assume it's at least like 1 gigabyte of disk space for each and every clone, and it takes a lot of time. That's not the best idea. But one thing you can do is that once you cloned the core Git and online Git, then you can use this -- reference switch of Git clone, and that means that I'm cloning this URL. In the Gerrit case, that would be this hello Gerrit /core. But don't download everything. I mostly have what's needed. So you refer to this core directory, which is a previous clone. And that means that in your new clone, you will just refer to all the missing objects, saying that in case it's missing in the local object store, then I have that other clone already and look there instead of complaining that the object is missing. Which means instead of 1 hour plus, it's a matter of seconds to create a new clone. So that's very useful. You can also use that with our GitLab, or you can also use that on GitHub. So just in any case you want. Also, in case you don't like this reference clone, which is a bit hidden, and you can make the mistake that you delete the original reference repo, like the core one. And then you have some other clones which are referring to that one. You can just delete that, and nobody will warn you that that's a bad idea. Instead, you can do this Git work tree, which is much newer. I don't use it personally because switching to that would, mean changing everything and recreating the whole setup. But if you prefer doing that, that's also fine. It's basically the same tree, just with some more explicit user interface. Another thing that can be a bit confusing with Git is that each and every commit has an author date and a commit date. And what is a bit non-intuitive is that if your workflow is like you write to create something minimal, which is ugly but at least working, and you commit that, and then you incrementally improve that work up to the point that you can say that, okay, this is solid enough, it has tests, it has enough documentation, the actual code is like not obviously breaking anything else, it feels clean, then you publish that. But it might take, in worst case, it can take you a couple of days to arrive to that state. And the Git author comment, the Git author date will say the earliest time when you created your quick and dirty version. So that's a bit misleading. There is no single date that can be attached to your work because it was a duration, not a time point. But anyhow, that's the earliest time. And the commit time is kind of the latest one when it passed review and it passed CI and it's actually going in. So it's useful to be aware that there is the author date and the commit date. In case you cherry pick over branches, then the commit date is changing, but the author date is not changing. So it might happen to you that just mentally the real date is actually closer to the commit date, not the author date. So in case you prefer that, then there's a Git config option to say that this pretty format of the date should be the fuller by default. Fuller means both the commit, both the author and the commit date, not just the author date one. And also there is this git log that's pretty, where you can say which format you prefer. Just be aware that there are these two dates and what's the actual semantics of those dates. What else we have? So it's fine to have Git for the version control, but Git itself does not do code review for that. It does not do CI for you, and so on and so on. So for core, we use Gerrit for the actual management of the repos and code review, and for online we use GitHub, which is a whole different world. So let's focus on the core Git side first. So for the core Git, you can always do things manually, and that's all fine. It's probably useful in case at least once you do it this way, so that you understand what you are doing. And then there is some helper tooling on top of that to make that a bit easier. So when you push for review, then what you manually can do and what is actually happening behind the scenes all the time is that you do a push to a remote repo like origin. And then the first syntax is that you always specify what you push, what's the source branch and what's the remote branch. And for the more like the remote run. And this Gerrit hack is that instead of the real branch, you can always say, so what would the full pass for that would be refs has something. And then the Gerrit hack is that there is this fake branch called refs for something. And if you push there, that creates this new change at the Gerrit level. And that's something that you can always do in case you only have Git itself, which is quite typical on Windows where you don't have Linux style package manager to install Git review or other tools. Then this is something that you can always do, and in some cases that's the only thing you can do. On Linux, what's very handy is to install the Git review tool, which is working from this configuration file, which is part of the repo, this .git review. So in case you are on some whatever branch in col.la, then the one who creates the branch, like cl.la or Andras or somebody else, then this Git review is always updated, and they do the work for you to know on what branch you are and so on, which means that you can just type git review and it will do basically this for you, but you don't need to remember on what branch you are, what's the remote, and so on and so on. It will just go. One thing that which might be a little bit too much for automatically doing everything for you is that it will automatically rebase your local state for you in case you don't want that, because you want to explicitly submit your change in a way that you know what's your baseline, and it's actually important that that's the baseline and you don't want to change that. Then this dash uppercase R can say that don't rebase for me. So that's something at least I type a lot personally. And this is the submit side. There is also the cherry pick side when you review some change as a reviewer. It's a nice thing to just read the change, but in many cases you want to actually try it out locally before saying your opinion. Perhaps you want to like inspect how the code is executed in a debugger at some debug statements. Just test it manually. Let's say the code is there, it has no test case. So the unfriendly answer would be, I can't test this because there is no test case. You can be a little bit more friendly when you do code review and say that, okay, at least you try it out locally. It does work. Then the code is probably correct, but wouldn't it be nice to also cover it with the test? So this kind of thing is when cherry pick from Gerrit is interesting. So again, the manual way is that you go to the Gerrit page for the relevant change. There is this whatever hamburger menu on the top right with this three dots, and then there is a download menu item, and there cherry pick gives you a command line, which is basically a git fetch of some git ref. Ref is kind of a branch, but ref is branches is a subset of refs. So there are many things that are references but not branches, like tags are in that category. And all the Gerrit changes, which are nominally not part of the repo, are actually technically in the repo, but they live under this refs changes namespace. So anyhow, it gives you this command line what to fetch. And once you fetch it, then there is this local fetch have ref that you can work with. And then you can cherry pick it to your local branch. And in case it was a small change and you already have a build, then it's a fast way to have that to be reviewed change locally, and you can see what's going on. Again, Git review has a -x switch to just fetch a change from the server without being two variables. Sometimes it's reasonably rare, but sometimes you want to exactly check out the state that is represented by that proposed change, like that commit, which means that you don't want to cherry pick it to your local state, but you want to check out exactly that baseline that was used by the submitter, like the author of the change or owner of the change, and you want to have exactly that state. Let's say that latest master is all good, but that change is broken. Then either the change itself is broken or it's already a broken baseline. So perhaps you want to check out or some build problem that you don't see. Was that fixed already? Or if you go back to exactly that state, then perhaps it will still occur to you. So in those cases, it's useful to check out. Or in case there is a pending change and you don't want to touch that change, but you want to create a next change on top of that, then you need to exactly check out that state, and then you can create your additional commit on top of that. So check out this form for that thing. Git has this hello Gerrit script. In case you are happy with that, then use it. But for one hand, it's only in col.get, so that's a bit limiting. There are many other repos on Gerrit, and they don't have this script. And those, in case you know how to do this manually, how to use git review, then there is not much left to be solved. So you can happily live without that algorithm script. Then there is the online side. So for online, we use GitHub, which is a whole different beast. Again, you can submit changes and fetch changes there. So for submitting, it's a bit similar for, like, I guess most of you are committers for online Git. So what's the easiest is that you push to a private branch, which is not special at all. It's really just a branch with a private and your nick as a namespace. And then when you do that push, then GitHub will print out a URL for you. You click on that, and you can create the pull request, which will create something which is similar to the Gerrit change. There is some command line tool called GH, which would be a short for GitHub, which can kind of do this for you. But even that one is like very complicated compared to the good Git review on the Gerrit side. So there is a G script in the root of the online repo, which has a review subcommand, which is more closely doing what Git review does for Gerrit. So you can just type G review and it will do it for you. Now, fetching is a little bit more complicated, but in case you saw that it's impossible, then the good news is that it is possible. You just need to type a bit. So what you can do is that in case you are reviewing a PR, and again, before saying your opinion, you want to try it out locally, then either it's a fork of online, which is the source branch for the pull request, then you need to explicitly use git remote to add that new remote, and then you can fetch from that remote. You can check out a new branch. Mentally, that's probably just the name of that person because I'm reviewing a change from somebody. And then once you have that, you can build that, you can try it out. You can also add new commits there. You can push it back. You can even rewrite history in case you want. And in case you were rewriting history, like you committed, you changed the commit message, for example, because it was poor, but it's easiest to just fix it yourself and then approve the change rather than asking the submitter to fix that for you. Then you can do a force push. In case you do a force push, it's very useful to not do an actual force push, but there is this force release which says that force it, but only in case what I believe is the remote state is actually the remote state, which means that you fetch that change, you did your changes locally, and in the meantime, the submitter committed something else on that branch that you won't silently overwrite. So it will overwrite in case there is no data. It's basically reducing the chance that even a force push will destroy some data for you. Then in the online case, there is this difference between a fork repo versus a private branch in online Git. We arrive from this GitHub Gerrit background, so typically we work with these private branches, but the typical GitHub style is to fork the repo and then create a branch there. There is no big difference, do it as you like. It's just easier for committers with the private branches because then you don't need to create 30 remotes and reviewing changes from others. What else? Yeah, that's probably mostly it. Then there is actually, like, there is a way how you decide if how you do the actual code review on the Gerrit side and the GitHub side. So let's deal with Gerrit first, core. Both of them has a positive and negative signs. So I'm just listing the positive signs, but you know what's missing, which means that it does suck in that other area where GitHub excels and vice versa. So the plus side for the Gerrit sign is that one local comment turns into exactly one remote change, which means that that change can have multiple patch sets, so kind of versions of that change is multiple patch sets. You don't have to think about branch names before publishing. You just In case you want, then there is a remote master, there is a local master. You create a fix, you commit it, you submit, you get an auto-generated number. Be done with that. It's easy. You can review the commit message in case, for example, you notice that due to a typo, the commit message is actively misleading. It says the opposite of what the code does. It's very useful to comment there and say that, hey, is this intentional or do you want to fix this? And so on. Also, you can review each and every commit one by one. In case somebody did a lot of work, 50 comments, and you are tasked to review them. One way to do this is like split it up to small chunks. You review each comment one by one, and perhaps today you have time to review 2 comments, but at least you progress, and eventually you get to the final state at the end that it gets reviewed. Also, in case you want to cherry pick over the different branches and the change is trivial, it's simple, there are no conflicts, and so on. So it's for the happy case, then you can just do that on the web UI. Of course, you can't really test what's the end result, but in case it's small enough, then that's fine. You can cherry pick on the web UI. Now, when you cherry pick between branches, then you can have this web way and local way. So as mentioned, the web way is easy, and in case you are happy with that, then it's fast and all good. Trouble is that it's not there on GitHub. And the other benefit of a local cherry pick is that when you cherry pick, then for the actual cherry pick, you are owning that change. So it's your responsibility that it works, but you propose to be integrated should be probably something tested, and you don't just throw random changes on the wall and hope that the reviewer will try it out, who might also just read it in a web browser without actual testing. So in case you want to be a little bit more responsible, or the change is more complicated, or there are conflicts, then you can do the local cherry pick. You can test it. You can try it out. You can resolve conflicts and so on. Why did I leave out the GitHub side? I wanted to. Okay, that's interesting. So it sounds like I left out a slide on GitHub for like what's the plus there. But basically the plus there is that kind of everyone is on GitHub, so that you don't really need to register in case you commit fixes to random externals of code. Yeah, that's very convenient that you don't need to create logins on 20 other so-called SSOs of that project. Also, you can create explicit branches. So in case you have 10 changes which are really belonging to each other, then just because they are in some parent-child relationship, they can be explicitly grouped to a group of comments in pull requests that you like. Also, you can so that's positive. Of course, the other is also true that you can't review the commit message. You can't review commits one by one. You just get a single diff and you need to comment there. Fine. Then guess this is the last one. So it's fine that you clone the repo, you do some work and you submit it, but in case everyone is just sending out changes and we are not really reviewing what's incoming, then we are not really working together. So you want to somehow stay up to date and be aware of what others are doing. Or at least if you don't do that, it's very recommended that in some way you at least build some understanding of what others are doing. So there are a number of ways to do that. One way is that you can do this polling. So you can go to the Github or Gerrit or Free Desktop CJIT interface and just view that page from time to time and see like what are the new ones, new comments there. And in case something is interesting, then you can even read the contents there and so on. You can also do just a git pull locally, and git pull will tell you what was the old and new comment for a given branch. So you can then use GitLab and just read the list of those comments. And again, see if something is interesting there, then you can read the actual diff of that comment. And there is also the push file. So for LibreOffice, we have the LibreOffice comments mailing list where mostly each and every comment generates a new email, and then you can read that in case you prefer consuming information that way. That also works. There used to be a comments mailing list for online, but it's not really working at the moment. So that's not really an option. Yeah, I guess that's mostly it. Is there any questions or like something I should expand on?
Thank you, Miklos, for presentation. And now, guys, questions, tips. Attila,
No questions, thank you.
João,
No questions, thank you.
Mevan, questions.
No questions, thanks.
Okay, András,
No questions, thanks.
Bayram, questions. Okay, Kellen, questions.
Yeah, no, just an observation. For rebasing, if somebody uses GitHub normal repository for Clever Online, it's possible for somebody else to rebase it if there's been some commit that caused Cypress test to fail or something. But if somebody is using their own fork in their own private repository on GitHub, then it's not so straightforward. So it's easier for other people to help you if you make change within the normal repository. Though I do think there is some option to allow reviewers to rebase your personal account branch, but I don't know off the top of my head how that works. But anyway, worth mentioning, I think.
Yep, I think there is a GitHub option for that, and I think the default is that when you create a pull request, then you grant the maintainers of the target repo right access to that single branch. So basically, for all col.la Online committers, in case there is a pull request, then you can write to that source branch. But as you say, it's a little bit more complicated as over time dozens and dozens of these Git remotes are accumulating, whereas at least for committers at the project margin. Thanks.
Thank you, Kellen. Hussein.
Yes. Thank you, Miklos, for the nice presentation. One question that I have is about the way you manage LibreOffice Core and LibreOffice Online. They are on different, let's say, software for managing sources, GitHub and Gerrit, and the versions that you work with. I assume that if you were using, for example, Gerrit, you could use submodules or something like that, but how do you manage in GitHub and Gerrit together?
So some modules would give you an explicit way to decide when you want to upgrade the dependency. So assuming that LibreOffice Core would have 2 changes a year, and those would be breaking changes, then we would want to plan it on the online side when we want to upgrade. And that would mean that we decide that on this weekend, this is that weekend of the year when we upgrade. And then you carefully set up your submodule to always pin to a given commit from core and work against that. And then you carefully plan your upgrade, and then you do your upgrade via submodules to your commit, and then you are done with it. This can work with nicely with external libraries which don't have a stable API, and they are not really caring like what they are doing. It's let's say zlib in case that would have an unstable API. It kind of works. It did work 10 years ago. I'm sure there is innovation in that space, but honestly, we don't really care. We just want to use something and make sure that it's not changes. That's the use case for someone else. The need for us here, it's a bit different. LibreOffice is not really breaking public APIs, and we update core very regularly. So instead, what we do is that we don't use submodules. There is just simply a matching branch. So you can always go to the website and see that col.la master is working against which branch. Typically, it sort of works with core git master, but what's guaranteed, what we have CI for, is that the newest col.la branch is always on the core side, always works with the online git master, and then you don't really need submodules. So submodules is a good tool in case that's your problem. In our case, it's not really solving what is the problem. Thanks.
Thank you.
Thank you, Hussein. Clove, questions?
No really a question, but maybe a hint for submitting large related patch series to a system that uses CI. Most ignore the work in progress patches, like for example, the LibreOffice CI ignores those by default. So if you submit your patch series as a work in progress by pushing to rest for master with the present WIP tag, then they won't trigger builds, and then just put the topmost commit to ready, and only that will be built. So this saves on cycles and basically checks your whole series at once, and then you can check for errors, fix those, and don't waste cycles on CI for the rest of them.
Thanks. That's I love your feedback there. I guess many of us has this problem that we are too shy. We don't really want to share our work till we believe it's perfect, which means that you can easily lose some valuable work in case you don't publish soon enough. And these work in progress changes are either just writing it in the commit message or doing it properly as you described. Github also has these draft PRs, which is similar. That helps publishing half-done work, which is already interesting for others, but it's explicit that it's not fully done, so you don't need to feel bad about your current state of your work. Thanks.
Okay, thank you. Darshan, questions? Okay, Gulsha, questions? No questions. Go, Guy.
No questions. Thank you.
Thank you, Marco. Mike, questions?
No question. Thanks, Miklos.
I have some notes, if I may. First, hello?
I think, Mike, we can't hear you properly. Can you speak a bit louder?
I'm sorry, do you hear me now?
Yes, yes, yes.
Okay, I wanted to share some thoughts. One thing about the very first slide about an advantage of rebasing, which we use over the merging, is one of the advantages is that when you rebase, you can fix conflicts in the correct context of a single conflicting change instead of trying to fix conflicts from different changes in one merging change in the end. This is not really relevant for our workflow. I just wanted to mention. Then I wanted to say something that I sometimes forget about stashing and indexing. When you indexed some changes but using git add and didn't commit yet, then stashing would drop the indexed entries, would unindex them and stash. Possibly there is a command line switch for that, but I was lazy to discover yet. So just something that I happen to forget and now and again. When talking about work trees, I just wanted to say that work trees are very convenient when you work with separate states at once, as Miklos said. So they are really working technology in core. And now about branches. A trick that I use, well, not a trick, but I like when my local branches track origin, so that I can simplify rebasing when I work not in master, not in some remote branch, but in a custom local branch. So I create them using -b, then a local name, and then the name of the origin branch that these local branch should track. Yes. Somehow I git check out b nick, and here I use origin slash, for instance, master. So this automatically allows to track master, the remote master, not local master. And one thought about the allow Gerrit, which is advised not to use. It would possibly be interesting to merge it into G script, which exists both in core and in online. And if LO Gerrit would be functionality would be in G script, like G review, it would be also similar in the both repositories. Sorry for a long comment. Thank you very much.
No, thanks. Especially the Gistar sang is something that, in case you use a lot of long-term staging things, and Gistar, then watch out for that trap. What I typically do is that I stage changes at quite late, so I stage and then commit instantly. So there is rarely a stash between staging and committing, but otherwise that's a bit non-trivial. In case you have random changes, half of them are staged, other ones are not, and then you do a gstash. What happens when you do that? What happens when you restore? And so that's fine.
Okay. Thank you, Mike. Thank you, Miklos. Michael Stell, questions?
None.
Thank you. Ezine, questions? No questions. Pedro, questions?
Thanks for the presentation. I just want to add that if someone wants to get notifications for every push that happens on your monitor, that if they personal account settings, they find something along the lines of customized email updates, something like that. And you can set if you want to receive emails for every push or reviews, and I think there is something else. That's it. Thanks.
Okay, thank you, Pedro. Pranam, questions? Okay, Raj, questions? Timur? Okay, Timur. Okay, Miklos, seems Timur is asking.
Could you please read out loud that for me? I don't see
Do
the
origin, yes.
Slide.
What do origin logger, Gerrit, and SSH do? Second slide.
This would be the second one. But there is no SSH there.
Mm-hmm.
This one, right?
Mm-hmm.
Yes, that's one.
Yeah, so Gerrit is just an alias at an SSH level. In case you follow, so this is for call Git. So if you follow the GPK with the setup, then you can add this alias as an SSH level, and you don't need to type out the custom port and Gerrit liblock on. But of course, you can always do that explicitly as well, in case you prefer that one. Does that answer the question?
Yeah, but why do we need SSH at all? There. What does it do here?
It's a protocol of the URL. Of course, you can explicitly say, similar to the GitLab case, like you can also do this SCP style with the username, the server, and the path, and that also works. So it was just an example on how to use a reference claim. You managed to find the not primary intent of that example. The interesting part is more like this reference switch. Yeah.
Okay.
So clone it the way you like.
Okay. Thank you, Timur. And last is Vivek. Okay, no questions from Vivek. If no questions, then let's see next week.
Can I just have one quick question?
Yes.
With merge conflicts, I mean, I've been resolving them manually for years. Is that still the state of the art? Is anybody doing anything different to resolve conflicts?
If you ask me personally, I do the same. There are some merge tools that you can drag and drop lines from here to there. Feel free to use that if you like, but be aware that the more automagic and more auto resolution these tools do for you, the more danger it is that it does something for you manually, and you don't review because it reported success, and then it is merged, and then later it will be more expensive to fix that. So there is a bit of trade-off there, but I don't think there is anything bad with the manual resolution.
All right.
Yes. Well, actually, I use Beyond Compare, which is a proprietary tool, but yeah, it does the job, and it looks quite nice.
Yeah, and there are a few others. If you look at the Git documentation, you can use that if you are happy with that, no problem. But what was done for you automatically is still going under your name as you send out the commit. So you are responsible of the resolution, even if the tool did it for you. To be aware of that catch, but otherwise it can be a great productivity boost in case you like that. Thanks.
Okay, thank you, guys. Other questions? Looks like no question. Okay, thank you, everyone. See you next week, and bye-bye.
Bye.
Bye.
Thank you.